Today we're going to look at inverse trig ratios, and it's actually pretty simple. It's really not any harder than what you've been doing already. But we need to review functions for a second. So take notes on this part of your worksheet. So we're going to create function g, and functions can do anything. And functions have two sets. The first set is called a domain, and the second set is called a range. And the domain has a list of items in it. In mathematics, it's usually numbers. And the range has a list of items, again, usually numbers. And the function attaches items in the first list to items in the second list according to one specific rule. Well, I mean, it can attach them however it wants, but in order to be classified as a function, it has to follow one rule. So let's say I had the number 4 and I attached it to the number 8. And then 3 got attached to the number 5, and 6 got attached to the number 1. That is a function. And a function, the rule that a function must follow is that every item in the domain is only attached to one item in the range. So things in the first list are connected to things in the second list, but nothing in list 1 is connected to two items in list 2. So don't write this, but if I had another number like 7 and I attached it to 1, is that okay? Careful. Is everything in the domain attached to one thing in the range? Yes. This is still a function. Okay? What if I did that? Now it's not a function. 4 can be connected to 8, but it can't be connected to 8 and 5 at the same time. One analogy I like to use is if you talked about if the domain was all of the people in the classroom, and then range was the city they lived in or the city they're nearest to for you people in Outer Elmo, then can one person live in two cities at the same time? No. You can only live in one city at a time. Okay? So this is not a function, but if I had another number and added it there, it still is a function. Okay? Now the inverse of a function means take the domain and slide it over to where the range is, and take the range and slide it over to the domain. So my new domain for the g inverse function is 8, 5, 1, and my range is 4, 3, 6, and the lines are still attached to where they were before. Does g inverse represent a function? Yes. Okay, now don't draw this, but if I were to connect that line, how would it connect over in g inverse? So 5 would go over to 4. Is that a function? No, because 5 is going to two places. Okay. If I were to have an 8 down here and connect it to 1, oops. So 4, 4, 3, 6, 8, here. Is that a function? No. So if we want to have a function that also has an inverse function, then it needs to be what is called one-to-one. Is that really important there, Dylan? Maybe you should take notes. So one-to-one means everything in this list has one line. Everything in the second list also has one line. So in order for it to be a function and be invertible, everything in this list and everything in this list has to have a single line. Okay, so go over to function f. We are going to look at a specific trig function called the sine of theta. So pull out your calculators and let's type in 30 degrees. In your calculator, type in the sine of 30, and you get 0.5. So over here, I have 0.5. Well, what about the sine of 45? The sine of 45 is 0.7. Yours isn't working? So push, if yours isn't working, push mode. The third one down, you need to go over and click on degree. There are two ways to measure angles. One is radians, one is degrees. You don't yet know what radians are, but you will in a week or so. So you have to be in degrees for this to work. So the sine of 45 is 0.7. What about the sine of 60? Sine of 60 is 0.86. And then I can draw the arrows. Is this a function? If every single time I do sine of 30, am I going to get 0.5? Yes. Is there any other angle that I can do the sine of and also get 0.5? So will the sine of 30 always give me 0.5? Yes. Can 0.5 only be created using 30 degrees? If you're doing the sine, the answer is yes. So this is 1-to-1. Every angle on the left side is matched to every percentage on the right side. Now let me show you how this works. So what I've done is built a diagram, and I can't exactly get 30, but I can get close. That's close enough. So here I have a picture. This side over here is 2.61 inches. The hypotenuse is 5.23 inches. And remember, sine is opposite over hypotenuse. So at 30 degrees, O is 2.61 and H is 5.23. And notice, 2.61 is exactly half of 5.23. So this calculation here says if I take the measure of DF and divide it by the measure of FE, I get 0.5. So whenever the angle is 30 degrees, the length of the opposite divided by the length of the hypotenuse is 0.5. We also checked 45 degrees. So if I move this to 45, oh, I got that one perfect. So 2.61 divided by 3.7 is 0.7, which is what our calculator gave us when we plugged in the sine of 45. If I move this angle over to 60 degrees, I should get 0.86. That's pretty close. Okay, so your calculator just tells you what the percentage is going to be without even having to look at a triangle. Now, I can change this. So right now I have 2.61 and 3, but if I lengthen the triangle and then I go back to 60 degrees, the triangle has now gotten bigger, but notice the ratio is still that 0.87. They rounded it up. So that ratio has nothing to do with how big the triangle is. It's just comparing one side to the other. As I move this closer, how big can DEF be, the angle DEF? Can it reach 100? Can't reach 100. What's the biggest it could be? No, you're 10 degrees off. If we have a 90-degree angle here, I can't have a 100-degree angle. That would put me over 180. So notice, as that angle gets bigger and bigger, what's it getting closer to? It's getting closer to 90 degrees. Now, as that gets closer to 90 degrees, watch what happens to this measurement. That percentage is approaching what? 100%. And actually, if you get close enough, it rounds it up to 100. Because once you get to 9.995, then it rounds it up, because it rounds to 2 decimal places. So this angle can get really close to 90, and this side, the ratio, can get really close to 100%. What if I went the other direction? As the angle gets really small, what's going to happen to the percentage? It's going to get closer to it's going to get closer and closer to 0. Okay? So, each one of these ratios is tied to a single angle, which means we can invert this. We can flip them around. So if I have 0.5, and this was actually 0.707, and the other one was actually 0.866, I can create 30 degrees, or 45 degrees, or 60 degrees. And you still use the sine button, but you don't use the regular sine button. You use what is called the inverse sine button, which is written as sine to the -1. So instead of pushing sine, you push second sine. So everybody do second sine of 0.5, and it should give you 30 degrees. For the next one, second sine of 0.707. Now that's really, really close to 45 degrees, so it's close enough. And then second sine of 0.66, or sorry, 0.866, should be really close to 60 degrees. Why are those numbers not perfect? I didn't use all the decimals. So this number is not totally correct. I rounded it off, and because I cut those decimals off, then my angles are going to be just a little bit short. Okay, so one thing you need to remember, if you have angles and you want to turn them into percentages, you use sine, cosine, and tangent. If you know the percentages and you want to create the angles, you use sine inverse, cosine inverse, and tangent inverse. And you have to be able to keep those straight in your heads. If you know the angle, use sine, cosine, tangent. If you're looking for the angle, use sine inverse, cosine inverse, and tangent inverse. All right, down below we have a triangle. And we know 2 of the measures of the sides, but we don't know either of the angles. So let's find angle B. And I'm going to write on the board, SOHCAHTOA. If I want to find B, am I going to use sine, cosine, or tangent? Sine, cosine, or tangent? Well, if this is theta, what's the name of this side? This is adjacent, and this side would be hypotenuse, and which one uses those two? Cosine, but remember, we're looking for the angle, which means we have to use inverse. So cosine inverse of the adjacent side divided by the hypotenuse will tell us how big the angle is. So inverse cosine of 8/11 is 43 degrees. Now the nice thing about sine and cosine, if you get your sides mixed up, it's not going to give you an answer that makes any sense. If I accidentally did inverse cosine of 11/8, it gives me error. Why didn't it work? Can this side be 11 and this side be 8? No. The hypotenuse has to be bigger. So that won't work. Okay. So I know the measure of B. How will I find the measure of A? Well, if I pick A as my theta, how does that change the labeling of the sides? Now this one is adjacent, and this one becomes opposite, and the hypotenuse remains where it is. So we're now dealing with which trig function? Nope, not adjacent. We don't know what it is. We're now dealing with opposite and hypotenuse, which is the sine. So sine inverse of 8/11ths will tell us how big angle A is. So sine inverse of 8/11ths. Oops. Sine inverse of 8/11ths is 46 degrees. Oh yeah, 46.6 is probably good enough. Turn the page. So we have a bunch of stations with information given. In each one of these stations, we need to figure out what angle is created with the given measurements. So all of the measurements are listed. Sometimes wall is the same as height. That's what it means, the height of the wall. So the first piece of information it gives us is ground, but it's in feet, and we want to do all of our calculations in inches. So what is 9 feet in inches? What's 9 times 12? 108. So this is 108 inches. The height of the wall is 10 feet 10 inches. How do you convert 10 feet 10 inches into inches? So it's 12 times 10, which would be 120, plus 10 inches is 130. So this is 130 inches. Okay. And then the eye level, the height from this person's eye to the ground is 65 inches. So now we need to label the lengths inside the triangle. So instead of looking at the whole picture, we're just going to look here. What is the length of the base of that triangle? 108. What is the length of the right leg of that triangle? It's not 130, because 130 is from here to here. Close. It's 130 minus 65, which just happens to be 65. So this is 65 inches. Okay. What trig ratio am I going to use? Tangent. Good. So we're looking for theta, so it needs to be tangent inverse. Second, tangent inverse of which one goes on top? 65, because that's the opposite. So 31 degrees. 31, I don't know, 0.04, I guess, degrees. So that's the angle necessary to complete that triangle. And for this worksheet, we don't care what the other angle is. All we're looking for is that particular angle. Okay, station 2. Distance from the wall. So we know that the wall is 8 feet 5 inches. 12 times 8 is 96, plus 5 more, 101. So this is 101 inches. And the eye side is 8 feet 2 inches. So 96 plus 2 is 98 inches. And then the eye height is 62 inches. So if this is 101, how far is it from here to here? So that'd be 101 minus 62, which is 39 inches. What trig ratio am I going to use? So I know the opposite and the hypotenuse, which is sine. So second sine of 39/98 gives me 23.45 degrees. You guys getting the hang of this? Okay. Take a look at number 3. The height is 7 feet 1 inch. That's 84 inches plus 1 is 87 inches. The ground is 6 feet 6 inches. That's 72 plus 6 will be 78 inches. And the eye height is 67. So what's this piece? If the eye height is 67 and the wall is 87, then this must be 20 inches. What trig ratio would you use here? So this would be adjacent and this would be opposite, which is the tangent. So second tangent of 20/78 tells me that the angle is 14.38 degrees. All right, one more, then you're on your own. Station 4. Ground is 3 feet, which is 36 inches. Eyesight is 8 feet, which is 96 inches. And the eye height is 59 inches. Do you notice something different about this particular problem? We don't know what the wall is, which means, what are we going to do with the eye level? Does it matter how tall this person is? No. The only time you need to use this number is if you're also using this number. So in this case, 59 is not needed. It doesn't change the problem at all. So which trig ratio is going to use those two numbers? Not sine, cosine. It's adjacent and hypotenuse. So second cosine of 36/96 gives me 67.97 degrees. All right. The answers are on the back, but you do need to show your work. And this will be due tomorrow. Good luck. Yeah, round it to a decimal or two. I'm not really picky.